equilibrium is a completely unstable condition. That is, when we first had submarines, we used to fill the water ballast tanks so it was just at equilibrium. And then if anybody happened to just drop a monkey wrench over, we could throw the ballast out and they would tend to nose over and get into great deal of trouble. When we began flying, then we came to what we call the stall. Stall came to a point when at equilibrium, at the stall, anything can happen, can go any kind of a spin. Nature abhors that equilibrium. She always, everything you and I know will always be one side or the other of the equilibrium. At any rate, this is the most expansive form of these vectors that I gave you. Now here's vector equilibrium. Can everybody see this all right? And I'm going to take this top face and move it, lower it towards the face on the floor. And this top triangle is not allowed to twist. It can only approach the triangle on the floor. Got two planes approaching each other. Understand? So this means this vertex will always be towards you here. And the vertex on the floor is towards me. So I'm going to do this. Suddenly it's collapsed to where the square are changing. They become diamonds, then ridgepole diamonds. Now the distance between the vertexes is such that the line is exactly the same as the other vectors. Therefore, I put in 6 vectors there, and you have the icosahedron. This is the icosahedron. Vector equilibrium then comes down to the first stable form, which is the icosahedron. The vector equilibrium itself consisted of 8 tetrahedra, each of a volume of 1, 6 1/2 octahedra. A half octahedra is 2, so 6 of 2 is 12. 12 and 8 are 20. The vector equilibrium volume is 20. And so it now collapses correctly. I want to show that 20ness of the vector equilibrium gets tightened up into the icosahedron with another set of vectors. 6 more are introduced, or 1 more unit of quantum. Now I'm going to keep lowering that triangle total on the floor, not twisting at all. And now it suddenly contracts to become the octahedron. That's a very beautiful thing you watch. All vertexes approach common center at a common rate. There's absolutely symmetrical expansion. Comes by up here and now contracts the other way. But the axis in my hands never rotates. Only the equator is rotating. Now I can go, supposing this is rotating in space, a group of stars, there's a mass attraction pull of another set of stars, and one then, this is trying to turn, and then it restrains this. What happens when you do that would be then, I move this around, it forces it to contract. If it's being forced to contract that way, then, remember, notice it's rotating this way. This rotates more and plunges right through and becomes the tetrahedron. We've gone all the way from vector equilibrium, icosahedron, octahedron, vector equilibrium. The octahedron is double bonded, tetrahedron is quadruple bonded. Quadrivalent, we call it. This way diamonds are with respect to carbon. We have no point to break open. So the maximum space employed by unity is a vector equilibrium, but all the structures are within it. They're contracted form from the whole. Now notice that this can then, tetrahedron, I've had it plunge that through like that. This can then immediately reverse itself, and tetrahedron can turn inside out. The other way. Just does it absolutely spontaneously. Just basic pumping. Okay. that identifies vector equilibrium